still want to leave out the things in the middle, what's happening between the times that I've noted. And so if I lay it out like that, this accounts for everything from A to D, including that which is in between, and so it's positive the entire time. So just a different way of displaying the exact same information. All right, now, whenever you're trying to figure out displacement, I find it's easiest to figure out where's zero first. So where's displacement zero?
Is that A and C?
A and C.
Well, you're the way you set up the problem, you said that the A is just after the ball leaves the hand.
Correct.
Oh, okay.
And C's like-
And the problem begins right after.
Yes. Yeah.
Gotcha.
That's what I was trying to say.
No, you got it. I'm
All right, so it's zero.
looking at it wrong.
Yeah, now, if the problem is set up correctly, and unfortunately there was one test where I messed up, but you can't go from positive to negative without going through zero. So, I got a bunch of pluses right here, I never have to go through zero, but here, I potentially am gonna switch signs when I go from here to here. Not always, but potentially. So, after it leaves the hand, until it gets back to C, because that's the only place that it can change direction, or change the sign, I should say. Displacement positive or negative?
Positive.
So there's a need positive, all three of those. So that's A to C with parentheses indicating I'm not including A and C. And then after passing time C,
It's negative.
yeah, because it's below my starting point, and so C, comma, D, bracket, negative, negative. And velocity. Where's velocity zero?
At B.
Yep, and only D. Now, some students in a problem like this want to have this ball on the ground. Yeah, the problem stops before it gets that far. So C is the only place where it actually, B is the only place where it actually stops.
It's E.
That's the point where it turns around. So before B, positive or negative?
It's positive.
After B,
Negative.
Negative.
so A to B, not including B, and then B to D. And now acceleration.
Oh,
It's negative, oh wait, sorry.
It's-
It's negative the whole entire time.
it's positive the whole entire time, shouldn't it? Well, once,
Up is
sorry,
positive.
That's filling, tastes great.
it's positive until it reaches B, right?
It's not gonna change though.
Exactly.
The whole time it's going up, it's slowing down, and then it reaches zero, and then it goes down.
Right,
So the whole
but,
time the acceleration
oh,
goes down.
so, okay. So for acceleration, it's constant, depending on, well, the problem, of course, but for this time it's constant because it's constantly accelerating.
The only force
Right.
acting on it is gravity.
It's
So
gravity.
wouldn't it be positive the full time though, because when velocity is negative, acceleration has to be positive, because it's opposite signs.
When the velocity is.
When velocity is
When it's
positive.
going up,
That's only if it's
Right.
against the.
slowing down or speeding up.
That's what
It's speeding up.
It's slowing down.
You throw an
Oh.
object in the air and it speeds up
It's going.
after it leaves your hand?
Well, maybe for a moment, I hadn't thought about it before, but maybe immediately after it left the hand, there is a moment.
There
No.
is-
Because like you're
Yes.
giving it force, so like,
Okay.
like, okay.
If there's not a force acting on the ball, then it's not accelerating, so after it's left your hand, it's not accelerating up.
You're
The
right.
only force
This
acting
is-
on it is gravity.
Okay.
This is the ball, this is gravity. And then they're both going down, because it's speeding up, but it's going down.
Okay,
So they're the same sign,
so it's always negative.
yes.
In this case.
There's
Unless
no,
we switch the signs.
there's no zero.
Right.
Okay.
Because I didn't care about the hand and I didn't care about the ground. Bringing in those into account, bringing the hand and the ground into account, suddenly we're dealing with additional forces, and I have to give you a bunch more information, like on the next problem I'm about to do.
Yeah.
Oh.
What if it was horizontal instead of a vertical with a constant of gravity?
That's how I looked at it, I looked at it this way, and it's still it helped me understand it better, because when you were walking back and forth, obviously you weren't walking up and down, you were walking
What
this
was
way.
Depends on where down is.
Okay, let's.
It's actually
not get
down
into
to
that.
definition, so the direction of the force of gravity.
On Earth.
So, there was some point, it was gonna be absolutely brilliant, you all would have just been amazed and walked out better people, and it's gone. All right.
It'll come back to you,
Yeah, 2 in the morning.
middle of the night, yeah.
So, acceleration is negative the entire time. From a force point of view, it's because the force of gravity is indeed acting down the entire time. Once it leaves the hand, there's no force from the hand. And we will go into that in probably excruciating more detail when we get to that chapter. Or from a speed up, slow down point of view, it slows down as it goes up. And so the acceleration is the opposite sign, makes acceleration negative. And then on the way down, velocity is negative, but it's speeding up. Acceleration is also negative. And so that leaves the turnaround point. So from a number point of view, if it's going, say, 5 meters per second there, 0 meters per second, negative 5 meters per second, my change is negative the entire time. So this is the whole time. Now, on the first test, there'll be more like the problem that we're about to do. I give you 4 different ways to express the answer. So one of them, I'm gonna have a chart like this. One of them, I'm just gonna have, a line of x greater than 0, x equals 0, x less than 0, delta x greater than 0, and so forth. And you would sort of write this in line by line as opposed to in a chart. One of them, I give you this, and another one, I break this down where you don't put plus or minus or 0, but you shade in. So this would be split. This was more interesting. So this is plus 0, negative, and you would just shade in. Now the advantage to shading in is because this problem that comes after this one on the test, I asked you to sketch a graph. So let's sketch a graph. So position, first time, velocity, first time, acceleration, first time, and an ever fading marker. Now, when doing the graphs on this one, it is, on the least more complex it gets, it's an iterative process, and it is just a sketch. So I'm going to mark down, this is A, B, C, and D. These are not spaced out properly given the situation here. The time going from C to D probably is going to be a lot less time than from B to C, but again, it's a sketch. I'll talk about the things that I'm looking for when I grade this part. So B. I personally find it particularly useful in order to at least mark down 0. So velocity is 0 at B, so get that marked down. I know it's positive here and it's negative out here. My acceleration is never 0. So one of the things I'm looking for is what you put on the graph doesn't match how you answered this. So whatever happens over here, this needs to be positive the entire time. As a matter of fact, it's going to kind of look like that. I do know one other piece of information here to help sort of tie it all together. I know that velocity is the change in position over the change in time. So if I have a position time graph, that would be my rise, and that would be my run. Velocity is just the slope, usually with an L, slope of the position versus time graph. So the other thing I'm looking for is if whatever you have up here, if I look at the slope of it, does that sort of match what you have down here? Well, here my velocity is 0, which means here my slope has to be 0 at time b. And what does a 0 slope look like?
Straight line.
Yeah.
Horizontal line.
No,
More
it's-
specifically, yeah,
Yeah.
horizontal, as opposed to the undefined one. So it's going to peak at this point right here. I know that it ends up lower than it started. Matter of fact, it ends up close to 0, not quite there. So it's a crude first sketch. I might go back and amend it later, but having done this enough, I know this one's supposed to look like a parabola peaking at time b. So this is the slope of this graph. So from A to B, is my slope positive or negative?
Positive.
Yeah. So my velocity is positive, but it gets closer and closer to 0. So it starts out positive, and then it becomes negative. I happen to know it's a straight line here, but it's not necessarily going to be a straight line. And my acceleration, which is the change in velocity over the change in time, or if I'm looking at a velocity time graph, my rise over my run, this is the slope of velocity versus time. The way I've drawn it here, I have a straight line, and so my acceleration, well, first off, the slope negative or positive?
It's negative.
Negative.
Well, it should not go past the time the problem exists. So do they work with each other? Well, my position was positive the entire time, it's positive the entire time here. I don't actually have it touching the axis here at point D, just above it. My velocity was positive until I get to B, then it's negative, and my acceleration is negative the whole time. So I'm good on that. What I have here matches what I have over there. If I'd asked for displacement versus time, then it would have just been this, but starting here at A, it would have shifted, it would have looked like that, just shifted down. It's like having a number line and then suddenly, you got points on a number line and just say, hey, why don't we shift to where 0 is? That's all we've done. My slope is positive here, my velocity is positive, my slope is negative, velocity is negative. The slope is negative the entire time, it's negative the entire time. And the other thing I check for is no sharp points. In math terms, it's differentiable at every point, but just note, this graph is not gonna look like that. If somebody actually did that, it would have splattered. Because the amount of force required in order to make a sharp point like that would kill it. Potentially, if it's sharp enough, it would be an atomic explosion.
I was about to say, you'd smash all the molecules together,
Yeah.
just flatten them, and then have to expand them.
Yeah, it would, bad news. Don't do this.
Yeah.
All right, questions before we do a test little problem? Please,
I'm a little confused. So with the velocity, you had it in the chart, you had it increasing until you got to B.
Oh,
Then,
I didn't say it was increasing, it's positive.
oh,
Until it
yeah,
gets to B.
positive until you get to B and then negative after that. So
Yes.
then, like, why would it be like, why is the line in the graph going only down?
It's positive until I get to B. After I get to B, it's negative. Now, in terms of speeding up and slowing down, this is velocity graph, this is not a speed graph. If I did a speed graph, so I did V versus T, that's point B right there, it would slow down until I got to B, and then it would speed up.
Oh,
This is
so
a speed
that's
graph.
a different type of graph. Okay,
Yeah.
That's what you were saying.
So if I'm going away from the origin, as I go from left to right, as I go away from the origin, as I go away from 0, I'm speeding up. So I'm speeding up this entire time, just in the negative direction.
I was confused at first too, because I thought if velocity was positive, the slope of the line would be positive, but you're more so worried about the x-axis, right?
Yeah.
In this graph,
Is it above the axis or below the axis?
right, that's what's more important. At first I was like, okay, this is good, that makes sense.
Just wait till you get on the test and suddenly you've got all sorts of ideas running through your head at once and like almost anything, you do the best you can at that moment. Other questions at the moment? I have time to set it up. All right, so this is a horizontal problem. It's just gonna go to the right and then bounce back. So A, let's see, this is, okay. Person is in a special chamber which has no gravitational forces acting on in it. Person throws the ball against the wall horizontally and the ball bounces back to him. Problem starts with the ball at rest in his hand, the instant before his hand starts to move. So his hand's right here, ball in it, and action, and starts to throw it. So, ball in hand, just before moving. B, time B, ball leaves hand. Last moment before ball leaves hand. So C, moment just before ball touches wall. Just before ball touches wall. D, moment of maximum compression. E, so those are only left and right. I'm drawing the letters like this just to differentiate them. Times going towards the wall are on the bottom, times coming from the wall are on top. So E, is moment just after touching the wall. F is when the ball, let's see, this is just before ball leaves the hand, so this would be the first moment before, or first moment it touches the hand on the way back, and then G, ball stops.
Wait, what does B say?
B is the last moment before ball leaves hand.
Could you clarify the difference between A and B for a moment?
All right, so I'm gonna throw a ball,
Right.
A, and then B.
Oh, okay, got it.
So unlike the last problem where the ball had already left the hand, this time we're taking it from when the ball's in the hand to when the ball's leaving the hand.
You know, it's funny looking at this from a no gravity standpoint. The force from the ball or I'm sorry, the force that he would have to use to throw the ball would actually send him backwards too.
Yeah, let's assume his back is against the wall or something.
Yeah.
Or he's strapped into something.
Or he gets thrown backwards, hits the far wall, because this actually is a prison scenario. There was a long, complicated storyline along with
Yeah.
it. And then he sort of bounces back when the ball's coming towards him,
Gotcha. Okay.
if you need it. All right, so it's the same exercise as before. We are out of time, but at least we've set up the problem, I hope, enough so that next time we can just start with this written on the board. And I guess the lab, you got the linear motion lab part 1 on Wednesday. Fun with the lab quest and motion sensors. And basically recreating some of the stuff that we did today.
Oh, then, are the videos for this under chapter 1 or chapter 2?
The videos mostly are, once we started into the whole position and so forth, that's chapter 2 stuff. I don't think I've posted Fridays yet.